Okay, here's a couple more proofs I'm going to walk you through for lesson 55 if you need my guidance. So number 5 I'm on tells us that this is showing a square. Okay, so let's think of all the things we know about squares because any fact a square has we can use in our proof. Okay, E and F are points on BC such that, okay, let's mark this part. This is a given. BE is congruent to FC. So this little piece is congruent to that little piece. We have to prove that. All right, let me mark it in red here. That AF is congruent to DE. Do you think that this might be a CP-CTC problem? Oops, I'm talking CP-CTC. The answer is yes, because we do have to get this triangle here, because AF belongs to it, congruent to this triangle here that DE belongs to. So when they're asking you to prove that these little segments are congruent, well, first you got to get the triangles congruent to each other. That's the goal. The goal is, with working with what's given and the square facts, get the triangles, yellow and green, congruent to each other, and then by CP/CTC we'll have the prove part. Okay, so statements, reasons. Let's go ahead and start with our first given, square ABCD. That's why these properties, knowing your shape properties are so important. You can really, really work with them in proofs, among other things. Okay, so I know that this is square. I'm going to start with the next given, and then I'll go back to the square stuff. So BE is congruent to FC given, and are those pieces sides of those two triangles? The answer is no, they're not. They're parts of sides, but they're not long enough. In the yellow triangle, you really want that side, BF. In the green triangle, you really want CE. How am I going to get that? By adding an equal thing to both equals. This is addition postulate coming up, people. So first, we want to prove that we're adding the same thing to both. So we're going to say EF is congruent to EF by reflexive postulate. Now by addition postulate, right, we're adding down. We're going to be doing here addition postulate. You're going to end up with bigger pieces because a part plus a part equals the whole piece. So BE plus EF is equal to the whole part BF. FC plus EF is equal to CE. All right, so now we've got, let me show you over here what's going on. I've got the whole top side of that triangle congruent to the whole top side of the other triangle. So I've got that, and it took me my 3 steps of addition postulate to do that. All right, now, can we think of any square facts that we can get something else in each triangle congruent? Are there any square facts? Yes. One that comes to mind is that squares have all right angles. So I can go ahead and say, well, then these are right angles, and so then these are right angles. I've got congruent angles for my triangles. All right, so angle B and angle C. They're right angles. Why? Because, and then the fact is, all, well, you don't have to say that. You could say a square has 4 right angles. Explains how you know. Now say that they are congruent to each other because all right angles are congruent. All right, so we've got 2 down. We need one more thing, congruent, bringing it back to another square fact. How about the fact that in a square, opposite sides are congruent? Well, actually, all sides are congruent, but we could totally say that BA and CD are congruent. That would help, right? Because then you've got that. So, all right, so we've got it. BA is congruent to CD. And how do you want to say this? In a square, all sides are congruent, or a square has opposite sides congruent? I mean, however you want to say it. All sides congruent. Okay, there you go. 3 things. Now say the triangles are congruent. So triangle ABF, triangle ABF is congruent to triangle DCE. Why? Well, let's look at the picture that's marked up. This is easier to see. It would be an angle in the middle of two sides. Two sides with an angle in the middle. Side, angle, side. And don't forget, we have to finish with AF. This is your last step. Congruent to DE by CP, CTC. You got to add that in there. AF, I'll put it up here because I'm out of space, is congruent to DE by corresponding parts of congruent triangles are congruent. Okay? I think what I'm going to choose to do is proof 2, and then I'll end the video here, because we haven't done one of these. Rhombus. Okay, let me shade it in. What's a rhombus? The PROE. So this is the rhombus right here. This one. Okay. And what else do we know? We know that this doesn't tell us anything. It just says SEO is a straight line. PEV is a straight line. Doesn't really help me. But this will. Angle SPR, that whole angle, see, SPR, is congruent to angle VOR. Okay, and that's it. Those are our givens. Prove that this little piece here is congruent to this little piece here. Well, what are those pieces part of? Hopefully you're starting to notice this pattern of triangles. Like they are the sides of these two triangles. So I'm saying, and my mind's thinking here, that we've got to get first triangle congruent to triangle. Then we're going to use CPCTC to get the sides of the triangles congruent. Corresponding parts of congruent triangles are congruent. All right, so I'm thinking get the triangles congruent to each other, that one congruent to that one, and how are we going to do that? Well, let's begin. We've got a rhombus. PROE is a rhombus. So hopefully you have in your head some rhombus facts that you can talk about so that you can get pieces congruent. What do rhombuses have? I mean, one of the first facts you should be thinking about is that rhombuses have all sides congruent. All sides congruent. If it's a rhombus, it's got all sides congruent. So what sides should I mention? How about the ones that belong to those green triangles? How about EO and PE? How about that? PE is congruent to EO, and the reason is because a rhombus has, remember you're saying your fact here, all sides congruent. Or you could say four sides congruent, or you could say adjacent if you want sides congruent. It's kind of hard to see that orange, so let me go ahead and mark it black. Okay? So we've got congruent sides, and those sides belong to our triangles. So if I could kind of, let's see if I can trace these triangles here. Let me move them over. Okay, kind of a bad job here, but I'm trying to show you them separate from the other picture. I've got two sides congruent. What else can I say to get those triangles congruent? Let's not forget the one that we've used so many times. Don't we have vertical angles there? So angle PES, I'm going to use 3 letters, is congruent to triangle or angle OEV because vertical angles are congruent. It's a fact that's always true. So look, we've got 2 things, so we need one more. The last thing we're going to use is this given here. And did you notice that they are the angles? Well, actually kind of bigger than what we need. I don't know if you guys are noticing that, but it's almost like they gave us too much. So if they're too big, what can we do to make them smaller? Think about that. Given. What you should be thinking of is, oh, there's got to be a way to shrink them down, make them smaller, take something away. The answer is subtraction postulate. I want to subtract something to get. So what I want to do, is there any way that I can take this out and take this out so that all that remains are the little purple angles in the triangles? All I want left are those little purple angles. So in order to get that, I've got to subtract out the blue parts. But in order to use subtraction postulate properly, I have to ask myself, am I subtracting equals from equals? So basically, are the big blue angles congruent? And can you prove that? Yes, we can say that the big blue angles, angle EPR is congruent to angle EOR, oops, angle EOR, because remember these are angles in that rhombus shape. You can say in a rhombus, opposite angles are congruent. So that takes care of knowing if they're congruent. Now let's do some subtraction here. So we've got the big angle that's too much minus that. What does that give us? It gives us the little piece in the corner, SPE. Angle SPE. And how about this big angle out here? Take away the blue chunk is what's left over, angle VOE. And that's subtraction postulate. And again, the whole purpose of subtraction postulate was to get the smaller angles that belong to just the triangles and not the rhombus, to just the triangles. And now, here we go. We got 2 more steps to go. We have 3 things in each triangle congruent. I'm going to say that the triangles are congruent. Triangle SEP is congruent to triangle SEPVEO. And then the reason is, here you go, 2 angles, side in the middle. 2 angles, side in the middle. 2 angles, side in the middle, ASA. And now our final step. Remember, this is the corresponding parts of congruent triangles are congruent. You are able to prove SE is congruent to EV. All right, and that concludes this video. Hopefully that helped.